Hi everyone, welcome to GuiNet Technologies. And today we are going to understand again Zscaler, right? So till now we discussed about the platform architecture, right? Packet flow of the Zscaler. We discussed about the control plane, data plane, statistics plane in the all previous videos, right? And I hope you guys are understand everything, elements, what is the central authority, what is the Zscaler enforcement node, what is the nanolog routers, and why we use an all nanolog streaming services, that is NSS, right? So now I'm going to move it further. Also, we discussed about the reporting and data privacy, right? And we clear about that why basically while pulling the log from the Zscaler while doing the troubleshooting or just getting any data from the Zscaler admin portal regarding the logs from the web insights, you probably get some times. So why that times is going to take? Why not real time or like very quickly data is going to pull? So we got that answer because this is the way architecture has been designed for Zscaler, and that's why this is going to take the much longer time to just match your company user ID, retrieve the real time information. To just they don't trust to anything, right? Even you are just going to access Zscaler for the any application, any services that follow the model that is known as a zero trust, right? So we discuss about what is a zero trust in here. So same thing, it is going to happen while you pulling the data. So that means it is not going to trust you at all. And further, we discuss about the step-by-step all packet flow, right? Traffic forwarding, like how it is going to be happen. What is going to happen when user is going to connect the Zscaler? What first thing is going to happen? How the connection ID is going to be allocated? How the connection tracking is going to be happen? And once the tracking ID, connection ID, it is going to be allocated. How the policy is going to be enforced for the users? And then how actual data three-way handshake is going to be completed, like, and data is going to be forwarded toward the destination. Could be the any Salesforce, like Workday, could be the Office 365, could be the Google, could be the YouTube, Amazon, any internet-based applications, any SaaS-based application, any your internal hosted that is again acting as your cloud services, that applications. If you want to leverage that Zscaler, then your outbound and inbound traffic, how it is going to be follow, right? So we discussed in the previous class in very details. So I hope you guys went through that. And if that all scanning, how the URL filtering, how the app like app filtering, like app access, thread, DLP, and like bandwidth, file type blocking, even the policy, advanced policy, how it is going to happen, IPS ideas, how it is going to apply, in which case the connection is going to be through, in which case the if policy is not going to match, then connection is going to be dropped. We discussed that. And the same thing is going to happen in the response traffic. There is one is the forward traffic and one is the response traffic. Like with the routing, we do the forward trace and reverse trace. So we can understand what is going to happen in the forward, what all the path is going to happen, and how the hope by hope the trace is going to be checks, routing is going to be checked. Similar is going to be happen, like always three-way handshake. Like if you're talking about the TCP traffic, it is going to always happen three-way handshake, and then after your connection is going to be through. So this traffic flow we understand, and we can say the packet flow. Now the next topic we are going to understand is like very I can say like one of the masterpiece from the Zscaler, that is a Zscaler single scan multiple action. Zscaler single scan multiple action. So probably you can see in the my module, when I started the module, you'll find that SSMA. So what is the SSMA, right? So this is the SSMA is known as a single scan multi action. Okay. So what does mean single scan multi action? So it's like if you guys are coming from the background of the Palo Alto, right? So let me just write here SSMA. And if you coming from the Palo Alto, you know that the architecture that is a SP3 architecture, right? So this is the architecture, SP3 architecture. And if I compare with this Zscaler, that is a SSMA architecture, single skill multiple action, they are going to be similar flavor, or I can say almost they are the same. Nothing different between these two, only the name is going to be changed. Both way, if I go in the Palo Alto, so if you see in my Palo Alto slide, because I'm the instructor of the Palo Alto, so we having the very good concept in the Palo Alto, that is that also the masterpiece of the Palo Alto firewall, that is the SP3 architecture, that is that having the capability single pass software with the parallel processing. So we know that in single pass software with the parallel processing, I keep doing discussion in the Palo Alto trainings, like it having the like capability, or it's like the trademark things. You can see the trademark, that is the nobody is going to use this particular name. So similar, Zscaler leverage the concept, or many vendors are leveraging the same concept, and they are developing their own products, and they are just using to just processing the traffic in a very fast way. So what is the idea behind it, right? Before we are going to talk about the SP3 architecture, or I'm not going to talk SP3 architecture because I'm basically on the Palo Alto, but the concept is going to remain same. If you know the SP3 architecture, you can quickly understand about the SSMA architecture, or what is the Zscaler single scan multi-action process. So first we have to understand how the traffic behavior was happening in the previous, before we having this kind of the like SSMA or SP3 architecture. What was the happening? So this is like say traditional service chaining. So what was the happening? Let's just suppose you having any single packets. So let me just draw the packet here. So let's suppose this is your packet. I'm drawing a little bit big packet because I just want to, you know, include a lot of things. So just think about this packet. Where I draw, let me draw here. Okay, just think about this is the packet, one packet. So let me just one packet, and this packet I can just include a lot of information. I start with the layer 3, or let me start with layer 2. So let me just draw it here. Let me just, so you could having the source MAC, you could having the destination MAC, you could having the source IP address. Let me just write here, source IP address. You might be having the destination IP address. You having the source port, you having a destination port, and you having the application details. So that is the app ID, you can say, or application or app ID, you can say application details. So I can use it, some other informations. And finally, I'm just going to use, or you can say any URL again part of the content. So might be I can write it here. Let's just think about any URL, right? Any URL detail. Or finally, we might having the more fields. I could show later on. I can show you the later on, but just think about last one is the data. Data is actually your content, actual content, actual content. So this is going to happen in the one packet. Trust me. So this is how the packet is going to be looks like. So if you just focus on these two packets, so what is these are? These are the layer 2 packet. These are the layer 2 source and destination MAC. If I talk about this source and destination IP, this is going to happen as a layer 3 packet, right? And if I go here, these are going to happen as a layer 4 packet, right? This is the layer 7. And just think about these are the all URL is advanced something. If you talk about the Palo Alto, we having a more fields, but just focusing on the URL, some any kind of the files, they all part of the content. And then actually your data is actual content. What like you sending one email, right? So email having the attachment. And before email going to be sent, all information required L2, L3, L4, L7, then only email can be sent, can be read, can be understandable. So data is something email you are sending. So if one packet having that much informations, right? So if you having any security device, just think about it's a firewall, or it could be the Zscaler, could be the firewall, because we are talking, or could be the Zscaler proxy or Zscaler. Think about this is also firewall, or some other vendor firewall, other firewalls, right? So once the packet is going to be hit, once the packet is going to be hit, this firewall have to process each and every packet. If when every packet is going to be processed, so first might be you have to check the layer 2. They will verify your source and destination MAC address. If it is allowed, or they having the correct informations, or they having the correct RP entries, then they are going to process. Then next is going to happen for the your routings. They're going to check the second routings. They're going to start check the your services, what port you are going to use. Then fourth might be going to check the applications. Then they are going to verify the URLs. Then they're verifying the data. And data could be having the multiple region. Your data might be affected with the virus, right? Your data might be you just wanted to protect the DLP. You don't want to leak the data. You want to do some sandboxing to just send the a special you want to send some sandbox or cloud based any kind of the scanning, then it is also going to apply. So URL data, everything. So if you do step by step for the one packet, if you do everything step by step for the one packet, definitely if even it is going to take 1 second, just I'm giving the example for make you understand. This is also going to take 1 second. This is also going to take 1 second, 1 second. Might be it's a very longer time, 1 second, but I'm just telling you. So 1 second. So how many seconds is going to run? 1, 2, 3, 4, 5, 6. So then packet is going to stay inside of the firewall for 6 seconds, and then it is going to out. Then it is going to be out. So this is your ingress interface, right? Ingress packet, or this is your egress packet. Okay. So egress packet. So before packet going to be egress, it have to stay at least 6 seconds inside of the firewall. If you go in this approach, so this was going to take a time, because if you considering for the one packet, but your firewalls going to be processed might be the thousands of packets, might be the hundred thousands of the packet, might be the millions of the packets, might be it could be possibility it could going to process the billions of the packets. So if such times is they are going to take, it is not having the very scalable, or your device having not very good performance. So this was the like legacy way of doing that, serializations that we call the serial scanning, one by one scanning. This is known as a serial scanning. Means the packet arrived, the first URL check, the antivirus check, then sandbox, then routing, then DLP, then your packet is going to be out. And it always consume a lot of times. So this was not sustainable as per the modern network requirement. When we talk about the modern network requirement, that means the next generation network requirement, right? So if we are talking about the next generation requirement networking, so we having the multiple users, they are sitting across the multiple countries, they're working from the hybrid model, or might be they permanently working from the any location, work from home, office. They are using a lot of applications. Some are using some kind of SAP application, might be their internal hosted application. Some are using some kind of SaaS-based application like Office 365, your Salesforce application, your Dropbox application, your Bloomberg applications. Could be a lot of traffic they are using. So if we having the very, big organization, and they having the very large scale of the employee or very large scale of the application, it's not sustainable. And this is why next generation network is not having capability to work on this traditional service chaining kind of the solution of the scanning the traffic or just processing the traffic. So Palo Alto come with the solution that is known as in very big initial, and it was very popular. Trust me, Palo Alto SP3 is a very popular. Similar, the Zscaler come with the SSMA solution, single scan multi action. They are the same. They are the same. Nothing different is going to happen. So what is going to happen? Let's say suppose same packet, your same packet now arrive in the Zscaler, right? Zscaler engine. So once the user send the traffic, this packet having the same exact informations, it is going to land to the Zscaler proxy, right? It's become the ingress packet. So let me just write here, ingress packet. So once packet landed here, they having all information like layer 2 information. Let me just write here, layer 2 information, layer 3 information, layer 4 information, right? Layer 7 information like URL, like advanced scanning, DLP, everything they are doing, and the data, right? So all information is same. But this time, this Zscaler based proxy, which having the special engine, they will do the again full traffic inspection. But this time, they will not put any extra latency. How they are going to do that? So you might be know about, because I am the Palo Alto trainer as well. So you might be know about this concept. Understand? You probably go on the airports. You probably travel in the any MRTs, metro, rail, right? You might be traveling any railway stations, any international buses. So you having a provision to do your check-ins, or you have to scan your belongings or your bags while just going inside of the airports authority or whatever you go. So this particular piece of the suitcase or whatever you have in the carry bag having a lot of informations, or I can say a lot of object inside of that, like you can carry the water bottles, you can carry the sunglasses, you can carry your laptop chargers, you might be carrying the some kind of the food items. So if let's assume that there is a one of the guy or security personnel sitting inside the channel and lot of queue inside of you, means this having a lot of queue, they all are standing in the queue. So people are once start going inside of the, let me just clear that and try to draw something for you all. So let's, these are the like people are standing here and they everyone having their suitcase. So probably it's very difficult to scan every person in very fast manner. You cannot scan because everyone having their suitcase carry bag. The security personnel standing here, if they start checking one by one person's suitcase by opening them, so probably it is going to take very longer period of time. It's not very fast. It is going to take longer period of time because one people having the multiple informations inside of the bag. So they have to check one by one everything. So probably these people have to cross this channel. It take 1 hour time or more than that. So it is kind of the frustrating. You can think this is something serial. Means you are just opening the package and you are checking everything very slowly. Your latency is very slow. Your network is not, or your scanning process is not too much fast. So due to this problem, what is going to happen? You are not very happy and your passengers are not very happy and they get frustrated here. So to mitigate this problem, they develop one kind of the sensor machine. So what you have to do, you can stay in the queue, no need to worry. You can process yourself via this channel and they can quickly scan you via the metal scanners or might be the hand metal scanners or auto scanner machines. But your luggage, your carry bags can be without open, can put inside of this machine. So once your carry bag is put inside of this machine, the scanners having a lot of sensor available here, inside of this machine. So they all will be activated at the same time. Means your packet inside of this particular machine and all sensor start scanning their process at the same time. So might be one sensor is taking 1 second. So every sensor is just going to take 1 second only, not more than that. Okay. So if every sensor is going to activate at the same time and they're going to sense your every object which is inside of, might be thousands of objects or might be the or items or might be the hundreds of items, they all are going to be processed via this box in 1 seconds. So you saved a lot of seconds here. I was just giving the 6 second examples, but you saved a lot of seconds here because you develop the sensors, they having the capability, they can work all together and they can give the same time output of the display screen in front of the any security personnel who is monitoring it. Is it relatable, right? Probably you guys must be went through the airport for the check-in purpose, and you know that like this kind of the crowd we have seen that. Okay, this kind of the crowd we have seen that we have to process by the channels, and one person is keep scanning and watching everything on the computer screen what you're carrying in your bag. So this is known as something single pass, multi action. Means in a one pass, you're doing the multiple actions for the scanning. And the Palo Alto firewall, the SP3 architecture, single pass parallel processing. The same thing, parallel processing or the multi action. Then only the understanding is going to be like same, name is going to be different. So you can see in the box, you having a lot of informations. You might be having guns, you might be having a sunglasses, you might be having some kind of the poisons. Everything is going to be scanned and they're going to give the same time output. But if you are going to scan, if you are going to open a bag and you just wanted to scan one by one, then definitely it is going to take a lot of time. Okay. So I hope you guys get this point. So same thing is going to happen. Let me just back again here. Let me just, draw the packet if it, I can able to draw. No, not able to, no worry. So same thing is going to happen. If your packet is going to arrive here, the packet having all informations, they are going to land on this particular Zscaler proxy SSMA, which having this capability. Means the packet inside of the SSMA, and see this packet in some memory. So one thing I told in the very beginning of the Zscaler sessions, packet never return in the disk. Means Zscaler having capability, it always process any packet in their memory. So hacker won't be, if I am doing something in my memory, so nobody can understand what I am thinking unless I can, let's suppose I'm giving an example. I have I have one password, in my mind, right? You can never steal from me. You can never get those passwords unless and until I'm going to tell you. But if I put those password read, I can write the password and put my locker. That means I'm putting somewhere in my data which is in my storage location, or might be the safe location. There is a high chance my data can be stolen. Might be I'm not in home, someone, some unauthorized person, trying to theft in my home and house, and they can go in my locker and broke there and get the data, and might be they can do some kind of the nonsense thing. You got my point? So the masterpiece from the Zscaler, the packet never return in disk. They always processing in the memory. But when the packet is processing in memory, still every action is going to be happen. Every action is going to be happen. What action? The scanning action. Like the packet having a virus, the desired URL he is accessing or not, the botnet, any kind of the worm vulnerability they are going to like triple X, cross scripting, DLP, DCCC. So everything like your content. So every policy, everything is going to be checked. And these all are going to happen at a one time. Let's suppose 1 second, 1 second, 1 second, 1 second, one. So same time your packet will be out, or might be the egress, it will go, to the destination in 1 second, right? So you save how much time? You save just 5 seconds time to just process the same packet. Earlier, we were doing the same thing, but it was just taking the 6 seconds by doing the serial kind of the scanning, because they have to look the things one by one. But when we change the way of working with the Zscaler or the Palo Alto firewalls, it has been completely changed. We are like getting the package, removing the, if you have to check the networking, you have to do the, networking headers also that is going to required in the Palo Alto, but here not required, because they never take care about the headers of networking. They just check about the content in the virus, because Zscaler is having a different concept. They're more about the webs. They're not more about the networks and all. They're more about the web traffic, SaaS traffic. So they just focus on what policy you want, what traffic you want to allow and deny. So they remove all IP headers once packet receive in the Zscaler memory. That is your gen. Gen is going to get all policy. How policy is going to enforce based on this traffic flow. So connection ID is going to be allocated based on the connection ID. Your memory is going to allocate it. And then only you can start sending your data. Without allocating the memory, you cannot send the data. This is the, you have to remember it. So first your connection ID is allocated, then your required company policy, whatever the, user base policy is going to be created, that is going to enforce on you. And according to that, you'll get the memory, and then you can send the packet, and then packet will once reach to the, Zscaler proxy, they will enable the SSMA to just scanning the process, and that is going to do the full inspection. And after that, it is going to just, scan each and everything. So this is SSMA. Okay. So this is a very good concept, and I must recommend, guys, these all the small Zscaler things you should know. I'll do all the labs later on, right? How it is going to be configured, how it is going to work, but let's understand theoretical first. So that's all for the SSMA. We'll move next for the traffic forwarding method. We understand the traffic flow, but what is the way of the traffic forwarding? We'll understand the explicit forwarding, and we'll understand the transparent forwarding, right? And then we'll understand the authentication. So one by one, everything will understand. But for now, thanks for, watching the GuiNet, Zscaler sessions. Thank you so much. See you again in the next video.